in a step-by-step fashion, we should come to the realization that water is all over the universe. How much water is out there? Unbelievable amounts. Why? Well, the best way I can explain it is you have young stars, they have a lot of oxygen and they have a lot of hydrogen, and as they cool and evolve, that hydrogen and oxygen combine, making water. And a lot of the water that the stars combine as they cool, shrink, and die stays put. It doesn't go out back into outer space, but a lot of it does. So you have the star keeping the water, and you have the star ejecting the water. So both happen simultaneously. And the water that the star keeps makes oceans, meaning ocean worlds. I printed out this article here from Ask an Astronomer. Has here written, where did all the water in the universe come from? And the question is put, hi, water everywhere, but where did it come from? Our solar system is made of star stuff. Did our water form during a supernova? How can H2O exist in stars? And the astronomer, now this is me making stuff up. This is an actual article. I screenshotted this. No, H2O cannot exist in stars, but H and O separately can. Hydrogen is the basic building material of the universe. And they miss it completely because they don't realize that as the star cools and dies, it allows the water to combine. So this is what they're referring to. Of course water can exist up here, but as the star cools, the water is combined, or the hydrogen and oxygen are combined, and they stay put inside the star as they evolve. And given that there are, from their estimates, 200 billion shining stars in the galaxy, I did a little graph here, and this is a very rough estimate. And being that young stars are between 0 and 300 million years old, intermediate age stars are between 300 and 600 million years old, and there's 200 billion plus respectively. I'll post this to the bottom, and it just keeps on going, which means we should have a hell of a lot of water worlds in our galaxy. I put a medium range estimate of around 6.4 trillion water worlds. This means objects that have a whole hell of a lot of water on them. I didn't actually estimate how thick the atmosphere is above the water, but I put the estimate as those are water worlds, meaning there's a lot of water on them. From small moons to Earth-sized objects, and even to objects that are possibly as big as Neptune, and between those sizes. So we have a lot of water in the universe. That being said, it's very easy to understand why they came to these conclusions, and it's also kind of weird. Again, this article is from September 13th, 2018, Water Worlds in the Milky Way. I'll link this to the bottom. Ignore a lot of stuff in here because it's very weird and haphazard. But basically the article is, how do planets get their water? And on the bottom I highlighted here, where's the water from? Despite our familiarity with our own planet, scientists still don't know the source of Earth's water. Well, the reason why they don't have any understanding of where Earth's water came from, well, it's very simple. Let me grab the other page here. Oh yeah, I put this diagram. I split it in two. When you split a star's evolutionary path into two separate parts, the planets over here and the water forming objects over here, naturally, when you look at this, you're like, well, we don't know where the water came from. It just had to come from somewhere. Yet, that's what stars do. They form enormous amount of organic molecules, and they form enormous amounts of molecules that are inorganic, and they form all the water in the universe. It's a natural process that the star undergoes as it cools and dies. And astronomers, they believe all stars are hot and can't form large amounts of molecules, but that's exactly what they do. Here's an old school as I think you'll remember doing this diagram right here. Um, the stars, when they're young, they're plasmatic, meaning they're so hot that they can't form molecules. The atoms are very ionized, they're very energetic, they can't combine together to form any type of molecules. But when you allow them to cool down, that plasma becomes gaseous matter. That's what a gas giant is. It's a very old star that's lost a lot of its mass, and it's cooled down to where the plasma becomes gas. It recombines into gaseous material. That's what gas giants are. That's what Jupiter is. That's what gray dwarfs are, Neptunes. And then as they continue cooling, that gaseous matter and superheated matter in the interior of the star starts to become liquid and solid material. And the solid material solidifies in the center. That's what forms the core. You know, the iron and nickel, they form first. And then the pyroxenes and the olivines and all that, they form on the outer layers. And then as the star continues cooling, all that water that formed in the very earlier stages just pools on the surface. Because, well, for a couple of reasons. One of the reasons I remember from my geology class is that it's basically an extremely explosive material. In other words, when you heat it really fast, it can explode. That's what fuels a lot of volcanic eruptions. Is there's still water trapped in the crust, and if that water has a chance to escape, it's going to escape explosively. But that water doesn't want to stay cramped up in the crust. It wants to come out. But eventually, all that water is going to exit the Earth, and the Earth is going to become basically bone dry. And of course, there's going to be a little bit of water underneath the crust. Like I think Mars and the Moon have a little bit of water underneath the crust. But eventually, that's going to come out too, and the Earth is going to become a dead star, like a dead moon. But I just find it kind of weird how even in 2018, the scientists are like, we don't know where the water came from. That isn't the question you should be asking. The question you should be asking is, are there assumptions that we've accepted to be true that are not based on observations? And basically, the observation that they ignore is that the hotter objects that are around are not mutually exclusive of the cooler objects that are around. They're actually one and the same. You combine those two halves and everything will make sense. All the life, all the chemistry, all the processes that we're familiar with on the Earth are a direct result of stars evolving, and the Earth in itself is a single, very highly evolved star. Alright, you guys, I think I made this video long enough, and keep that in mind when you read articles like this. Look out for where they're assuming things to be true, because they never say it in articles. They never say, well, here are all of our assumptions, and then these are the conclusions. No, they never question the assumptions. That's what education is doing to graduate students these days, is that they're pushing them into a worldview that doesn't allow them to question assumptions. And from my communications courses, those are the highest things inside of a community, inside of a tribal type community, that are blocking understanding, is that the assumptions are there and nobody knows that they're there. They're these invisible things that nobody ever talks about. Alright, you guys, take it easy.